Hello. Today I wanted to talk about profiling React application rendering performance. For a long time I was a little bit scared of performance profiling. Why? Because you open Chrome Performance tab, you see all of this and it's really overwhelming. It's so much going on here. So most of the time, rendering is not really a performance bottleneck in our applications. It's more about large bundle size or slow network requests. So these rendering problems, they usually don't just suddenly happen. Most of the time they gradually build up, and then suddenly you realize that user experience became really janky, but you actually have no idea why, no idea what's really the root cause of this problem. It's more like a death by 1,000 cuts. And so we just use the old debugging technique called I will comment out this line of code, refresh, and hope something changes. Of course, this is not optimal, and there are better approaches to do performance profiling. So today we're going to optimize this small application I built. It's a real application. It shows some of my cycling routes. So you can click here. It shows the map, the route, and the elevation profile. So the map itself is built using Leaflet, and the elevation profile is built using D3. So when we go with our mouse over the route, we see this indicator which shows the distance, the elevation, and incline. And I guess you see this is not a very nice user experience. It's really janky. So first of all, let's open our Chrome Performance tab. We click Escape and select this paint flashing box. So now the browser will highlight the areas of the page that need to be repainted. Let's see how it looks like now. So we see here we aren't actually repainting so much, just this indicator at the bottom of the page. So no problems here. Now let's record our performance profile. So we hit record, we do something on the page, we click stop. So what do we see here? Here we see, for example, how our application looked like at specific points of time. So here we see our frames. This red line here indicates that we were doing some significant CPU work at this time. So it's called CPU burn. It's whenever you see this red line, it's an indication that something bad is happening. And if we go to this frames panel, we see that instead of getting smooth 60 frames per second, we actually got like 1-2 FPS frames which is definitely not smooth. And if we go to the summary tab here, we see that we spend most of the time scripting, and scripting basically means executing JavaScript. We can also go to this timings panel, and we can use mouse wheel to zoom in or zoom out. And here we actually see the flame graph of our components being re-rendered and how much time it took. For example, it took a really long time to re-render this elevation profile component. So we could go deeper into this using Chrome Performance tab, but there is actually a much better tool for React for this kind of profiling. So in September, React team presented Profiler plugin for React DevTools. This plugin uses Profiler API. It is used to identify performance bottlenecks in React applications, and it will be compatible with time slicing and suspense. So let's go to our application. Let's open React DevTools. Here they are, and here is our profiler. First of all, let's just see what's happening here, what's happening in our application. We can click here and we can select highlight updates. And this will basically highlight components which are being re-rendered. And now if we go here, we will hopefully see this whole right part of the screen constantly flashing because the whole right part of the screen is being re-rendered, and it probably makes sense because we have to, these two components need to somehow communicate with each other. By the way, opening React DevTools will probably reduce your application performance even more, so keep that in mind. So we are re-rendering everything, but it's important to understand that re-rendering something in React is not necessarily bad. It's actually really cheap, and most of the time we shouldn't worry about it and start preemptively optimizing everything. Only if we have large amounts of React elements which are getting re-rendered, or for example we're doing some heavy computations inside of the render method, then we should start worrying. So let's disable this highlight updates and let's see what is this component. So here we have our details component, which consists of our header, our map, which is built with leaflet, and our elevation profile. And inside of elevation profile we also have this component which is responsible for showing the distance, the elevation, and the incline or slope. So let's look at the code of our details component. So here we have our details component. It's built using hooks, but it's probably not relevant for this demo. So here we have details, which consists of header, map, and elevation profile. And here we have our state management, we have our reducer, and to avoid probes drilling, we are also using context, which will make these two variables, the state and dispatch, available for all of the components inside of this context. And if we go to the header, for example, we see, okay, the header is subscribing to the changes in state, to the changes in context, and map does the same, and elevation profile too. So all of them are subscribing to these changes. And if we just log state and go back, try doing something on the page, we'll see that, yeah, okay, there are a bunch of state updates happening, of course, because we need to update the position of our indicator, and of course it's not performant. So we could probably restructure our application. For example, we could remove context, somehow move our indicator component out of this elevation profile. But for the sake of this demo, let's assume we can do that. Our components are structured this way, and yeah, we kind of have to live with it. So let's go to our profiler again, and this time we'll actually record some performance profiling data, the same thing we did in Chrome Developer Tools. So we click Start Profiling, we do something, we click Stop, and again here we see our flame graph. The size and color of these bars represent how long it took to render the component and its children. So, for example, gray means components were not re-rendered at all. So if we click here, we see, okay, sidebar wasn't re-rendered. Sidebar is this part. It makes sense. But our details was re-rendered. And here we see, for example, the header, the re-rendering of header was actually really cheap. So this greenish blue or bluish green, whatever, means that component was re-rendered, but it was really cheap, so it was under 1 millisecond, and we shouldn't optimize it. But this elevation profile is where our problem actually is. So let's look at our elevation profile. What's happening here? So we have some div, some SVG, all of it is pretty cheap, and then we have this linear gradient. And okay, if we look at the right side, we can see that our linear gradient element actually has 700 children, and all of these children are constantly being re-rendered. It's probably not that good. As I told before, large amounts of children being re-rendered could be performance bottleneck, could be performance problem. So let's go to our application and let's go to our elevation profile. So there is a bunch of things happening here, but it's not really important for our case. Here we have our linear gradient, and here we have our root, which consists of 700 GPS coordinates, and for every GPS coordinate we are creating this gradient stop. So actually we want to re-render all of this stuff only when our root is changing. How can we do it? So there are actually different solutions possible here, but I will probably choose the most obvious one. So first of all, we are going to extract this to a different component. Let's just call it gradient, and let's say export default function gradient, which will return all of this, and it has a root and x scale, which we are going to pass from our parent. And here we can just say gradient, and we'll say root equals root, and x scale equals x scale. Let's just check if it's still working. It does. Okay. So let's go to our gradient component. So actually we want to re-render this component only when some of these properties change. Actually only when root changes. How can we accomplish this? So if we go to React Docs, we can find this React Memo higher order component. So before React 16.6, we were optimizing our class components using React pure component or should component update method. So what React pure component and React Memo do, they compare the state and props, and if they stay the same, then the component won't be re-rendered. It's important to note though that it will only do shallow compare. And so React Memo is basically the same thing as React pure component, but for functional components. So let's go to our gradient component, and let's just say gradient is memo, and we will extract all of this. We don't need function. Just say that's an arrow function, and we'll say export default gradient. So looks good, right? Let's just check if it's working. Okay, it's still working. Let's do another profiling. We do our profile. It's still not very performant. And here we see, here is our memo component. And again, all of these children were re-rendered, and the memo component itself was also re-rendered. So why does it happen? Let's look at the variables we're passing to our gradient component. So they are coming from our elevation profile, and here we have our root, and here we have our x scale. So let's just log them. So let's just log our root. So what do we see here? Our root is just an array, no problems there, but our x scale is a function, and this function is getting recreated every time elevation profile is being rendered. And although this function looks the same, we're constantly passing different functions to our memo component because it uses only shallow compare, and it actually can't memorize anything because the x scale is constantly changing. So what can we do? Actually, we want to recreate our x scale, which is this part here. Oops. Our x scale, we want to recreate it only when we switch to a different root. So here or here. So how can we do this? How can we recreate this function only when the root changes? Well, we can go to the hooks API reference, and we have this cool use memo hook. So use memo will only recompute the memoized value when one of the inputs, so inputs is this array, one of the inputs has changed, and this optimization helps to avoid expensive calculations on every render. In our case, it's not really expensive, but we still want to memoize it. So let's do it. Let's just say our x scale is use memo, which returns a function which returns our scale, and our inputs array will contain our root. So let's just save all of this and check if it's working now. We'll just go to profiler and record some data again. Stop. And now we see our elevation profile and our memo. Our memo and our linear gradient is gray, which means that this part of our application was not re-rendered. So we already accomplished something cool. But if we look at our elevation profile, it's still orange. It's somehow still orange. It doesn't have any children which are getting re-rendered. So this div and svg, those are just nothing. And this g, so yeah. Somehow our elevation profile still takes large amounts of time to re-render. Why? So I assume there are some computations happening inside of our elevation profile. So let's go back to our elevation profile component. And yeah, there are some things happening here, but it doesn't really matter to us. So what can we do? We can measure some performance, for example, to understand which parts of our application are not performant. We can do it using this Performance Now API. Performance Now will return a timestamp, measured in milliseconds, and this is how we can measure some performance. We measure it, we do something, we measure again, and then we calculate the difference. So let's try it. Let's just say, there is like A is performance now and B is performance now And C is also performance now, and let's just log something. Let's say first part took B minus A. The second part took C minus B, and in total it took C minus A milliseconds. So we save it, we go back, we open our console. And here we see, okay, the first part was actually really cheap. The problem was this second part. So what's happening in our second part? We have these path and these functions. What the hell is that thing anyway? Let's log this too, and let's temporarily remove all of this. And if we go back, okay. So now it's kind of clear why it takes so much time, because this string is basically this whole SVG path, which is calculated somewhere deep inside of D3, and this path is what's actually responsible for this elevation profile area and this green-orange line here. So of course this computation is heavy. So what can we do? Well, we can do the same thing we did with use memo above. We can say use memo. We only want to recompute this when our root changes, and we will do the same thing here. We can say use memo. And we probably won't need this anymore. Let's go back. Let's go to profiler. Let's start profiling. Okay, and now we actually see that it took like only 1 millisecond to re-render the whole thing. So before it was like 30 milliseconds, and now it's only 1. So if we close our developer tools, and when we actually open the live version of this app, because it's important to understand that React development version of React and production version of React, they have different performance, and the React DevTools will reduce the performance even more. So if we check it here, we can see, okay, this is what I call smooth, and now it's a very nice user experience compared to before. And if we go to Chrome Performance panel this time, we hit record again, we do some performance profiling. We will see a totally different picture this time. So first of all, instead of getting this 1-2 FPS frames, we are now getting some nice, I wouldn't say constant, but 30, 40, 50 FPS frames, which is really nice. We don't have this red line on top of our graph. So it, of course, at first, when the first render occurs, when the first calculation is happening, there is a bunch of stuff happening here. We are calculating, but then it's just back to normal. And if we go to our summary, we'll see that instead of spending our whole time scripting, we actually had some time for style and layout calculations and actually painting something on screen. So yeah, we did a pretty good job at improving our performance. So yeah, that was it for today. Share, subscribe and like if you like this video. Thank you very much.